Hello everybody, today I can solve logarithmic equations by putting into exponential form. So, my steps for solving a logarithmic equation meaning an equation with a log in it, I need to isolate / combine my logs into a single log. Once I have that, I'm going to put into exponential form. I'm then going to solve the equation, and I'm then going to check. Now, what I'm checking for is you can't take log of a negative or 0. So if substituting the answer makes the number after the log negative or 0, then it doesn't work. So we're going to start off small, and we're going to build up to bigger. Start off here. I see a logarithmic equation, an equation with a log in it. So my first step is to isolate / combine the logs. There's only one log, it's by itself, so I don't have to do step 1. Now I'm going to put it into exponential form. So to put into exponential form, we've done a lesson on this already. We start with the base, we raise it to the power to get my answer. We do our cycle, 5 to the 4th equals x. From here, there's not much to solve. 5 to the 4th power, you can put that into the calculator if you want. That's 625 equals x. Now to check, if I sub in 625 for x, is that going to make this negative or 0? No. That's my answer. Number 2. My first step in a log equation is to get the log by itself and have a single log. I'm good. So I'm going to put into exponential form. B to the 3rd equals 27. Now to solve this, there's a couple different ways to do it. But we're going to do one that's going to apply to all of these, and this is going to come up a lot at the beginning of this lesson. This is a constant exponential equation. Constant exponential equation. Raise both sides to the reciprocal power. So that's another lesson that we already learned. So the reciprocal of 3 is 1/3. So I'm raising both sides to the 1/3 power. That gets the exponent to cancel. 27 to the 1/3 power. You can use a calculator if you want. You could do it mentally. The 1/3 power is the cubed root. We get 3. Will 3 make this negative or 0? No. So you are going to see constant exponential equations come up, and that's what you would do. Let's take a look at number 4. I see a log equation. It's isolated. There's not multiple logs, so it's time to put it into exponential form. The base to the power equals the answer. So it's x plus 1 to the 3rd equals 64. Now from here, it is a constant exponential equation. So to get rid of the constant, I raise both sides to the reciprocal power. That gets that to cancel. X plus 1 comes down. 64 to the 1/3 power. You can use a calculator if you need to. Again, the 1/3 power is the cubed root. That's 4. And now from here, I'm going to have to go a little bit further. Subtract 1 to get 3. Will plugging in 3 make this negative or 0? No. So I'm good. Why don't you try number 5 on your own right now? So please pause, try number 5 on your own, and then unpause. All right, I have log by itself, so I'm going to put it into exponential form. I get 5x minus 1 to the 1/3 equals 4. It's a constant exponential equation. So to get rid of the exponent, I raise both sides to the reciprocal power. The reciprocal of 1 over 3 is 3. Those cancel. 4 to the third power is 64. From there, I solve the equation. I get 13. Is 13 going to make this negative or 0? No. Number 8. Now for number 8, there's two different ways to do this. I want the log by itself. I want there to be a single log. There's a 2 in front. So my log rules state if I have something in front, I bring it back to the exponent. Now you could have also divided both sides by 2, but what I want you to do for these logs is to bring it back to the exponent. And that's one of the rules that we talked about. So now that we have that coefficient back in the exponent, I put it into exponential form. 4 to the third equals 5x squared. 4 to the third is 64. 5x squared is 25x squared. Remember, when you have an exponent outside parentheses, everything inside gets it. Let's bring this into space. I divide both sides by 25. Square root of both sides. Now, if you could have risen to the reciprocal power. You could have risen to the 1/2 power. It's the same thing. For square, I usually just like to do the square root. Because it's a fraction, I take the square root of the top and the bottom separately. The square root of 64 is 8. The square root of 5 is 5. Will substituting in 8 over 5 make this negative or 0? No. So that's my answer. So if you have something in front of the log, bring it back to the exponent. That's your power rule. So we have a bunch like that, which brings us to number 11. Again, my first step is to combine into a single log, which I haven't had to do in the other examples, but I do have to do here, since I have 2 logs. So I use my log rules to combine. Subtraction becomes division. So I write log once, subtraction becomes division, and it's 45x over 3. Now that I have a single log, I put it into exponential form. Since there is no base written, my base is 10. So 10 to the first equals 45x over 3. 10 to the first is 10. 45x over 3. I can divide those and get 15x. Divide both sides by 15. I can reduce that. 10 over 15 is 2 over 3. Will 2 over 3 make this negative or 0? No. So I'm done. Okay. Number 12, again, my first step is to isolate / combine into a single log. Since I have multiple logs, I need to combine into a single log. So I'm going to write the log once. The base of the log is 3. And since I see a plus, addition becomes multiplication. So again, your first step, you need to combine into a single log. If you don't know how to do that, then refer back to that lesson. Now, I put into exponential form. I do my cycle. 3 to the second equals x times x minus 8. 3 squared is 9. X times x minus 8. I can distribute. I get x squared minus 8x. And now we see Mr. X squared. And yes, Mr. X squared comes up everywhere, including log equations. He wants to party. Can he party right now? No. So I need to bring the 9 over. And then we factor. First sign comes down, negative, and a negative is a positive. Multiplies to 9, subtracts to 8, 9 and 1. Set each factor equal to 0. Now, will substituting 9 in make either of these negative or 0? That'll be 9. That'll be 9 minus 8, which is 1. That one's good. If I sub in negative 1 in for x here, that's going to give me a negative. Therefore, I have to reject that answer. And x equals 9 is my answer. Negative 1 would also make this one negative. If I did negative 1 minus 8, that would be negative 9. This can't be negative because I can't take the log of a negative number. And that's it. 13. We're going to kind of go through this one together. It's pretty much the same thing that we just did. I need to combine into a single log. So do it. Combine into a single log. As a hint, there's a plus. So that plus should become multiplication. So try that on your own. Okay, I'm writing log once. The addition becomes multiplication, so I'm multiplying the x and the x minus 3. Now there's no base written, so if there's no base written, I write my base in as 10, and we put into exponential form. So I want you to put into exponential form on your own right now. Ten to the first equals x times x minus 3. So now I kind of evaluate both sides. 10 to the first is 10. X times x minus 3 is x squared minus 3x. And now it's Mr. X squared. So follow your Mr. X squared story. I want you to finish it off from here. I'm going to ask you to pause it, finish it off, and then you can play it to see if you got it right. Okay, now that you tried it on your own, subtract 10 from both sides. 0 equals x squared minus 3x minus 10. First sign comes down, negative and negative is a positive, 5 and 2. X equals 5, x equals negative 2. Will 5 make any of these negative or 0? 5 would make that 5. 5 minus 3 is 2. That one's good. Negative 2. Yep, that will make that negative. It will be negative 2. So I reject that one. Your answer is x equals 5. All right, let's take a look at 15. I need to combine into a single log. So right now I don't have that. Also, since this 2 is in front, I need to bring it into the exponent. That's why in the earlier problem, I said you could have just divided by 2, but this one, if I just try and divide by 2, it's not going to work out so well because there's more terms. So, 2 hints. There's that hint, and then there's the subtraction. So subtraction is going to become division. I want you to try the first step on your own. I want you to combine it into a single log, and the only hint I'm going to give you is I'm going to write log once. The base is 4. So take about 20 seconds right now and try to combine this into a single log. Okay, it should have been x squared over x minus 1. Again, the 2 comes up in the exponent. The subtraction becomes division. Now that I have a single log, I can put it into exponential form. So it's 4 to the first equals x squared over x minus 1. 4 to the first is 4. And I get that. Now, again, this is just equation solving. It's something that we've done earlier this year. I see a fraction. So you need to know how to get rid of fractions in equations. To get rid of fractions, I multiply by the LCD. Those cancel. X minus 1 times 4 is 4 times x minus 1. My right-hand side is x squared. From here, Mr. X squared, I'm going to let you pause this, finish the problem off from here, and then you can see me go over it. So again, try to finish the problem off from here, pause it, and when you're done, unpause. Okay, let's finish the problem off now that you did it on your own. Distribute. Bring everybody over to Mr. X squared's house, minus 4x plus 4. Party time. Bubbles. X minus 2, x minus 2. Set each factor equal to 0. X equals 2, x equals 2. So it's the same answer, so there's only potentially one answer here. Will subbing in 2 make any of these negative or 0? 2 would be 2. 2 minus 1 would be 1. Neither of them are negative or 0, so your answer is just x equals 2. All right, let's do maybe just one more, and then after that, I'm gonna let you practice. Let me just look for a good one. I guess we can do 19. So, if I see multiple logs, your first step is to combine it into a single log. Why don't you try that on your own right now? Combine these into a single log. I'll give you about 20 seconds for that. I'm going to write log once. The base is x plus 3. And because this is a plus, I'm multiplying the 2x plus 3 and the x plus 5. Now that I have a single log, I put it into exponential form. Why don't you try that step on your own? I'll give you about 20 seconds to put this into exponential form. I perform my cycle. X plus 3 squared equals 2x plus 3 times x plus 5. Now it's algebra time. X plus 3 squared is x plus 3 times x plus 3. So I'm going to have to do 2 boxes. Or you can use square binomial theorem on the left. So I'm going to do x plus 3, x plus 3. I'm going to do 2x plus 3, x plus 5. I do that box. I do that box. X squared plus 6x plus 9. 2x squared plus 13x plus 15. So this becomes x squared plus 6x plus 9 equals 2x squared plus 13x plus 15. Mr. X squared, bring everybody over. Everybody's coming over. Factor. X equals -6. X equals -1. Now, I don't just reject my negative answers. I have to plug them in and see if they're going to make the log negative or 0. So when I plug -6 in, well, if I plug -6 in here, -6 plus 3 is -3. That one's out. If I plug -1 in, well, -1 plus 3 is +2. So that's okay there. If I plug -1 in here, 2 times -1 is -2 plus 3. That's +1. That's good. If I plug -1 in here, -1 plus 3 is +2. If I plug -1 in here, -1 plus 5 is +4. So even though x is negative, it doesn't make the log negative or 0. So -1 works, but -6 doesn't, because when I plug in -6, I mean, basically all these become negative. You can't have any of them negative. So the algebra can get a little nastier, but the concept remains the same. Combine into a single log, put into exponential form, solve the equation. A couple of little hints I want to give you. So first of all, I should have mentioned on number 20, I did mention the answer key. You're going to round to the nearest hundredth for this one, or 10th or 100th, I don't know, whatever. You're going to have to round, which means you're going to have to end up using quadratic formula at a certain point. And the other thing I want to mention for some of the questions, like this one, you are going to end up with a tricky trinomial. So you're going to have to use that method. So again, I know these questions can start simple. They can get pretty complicated. That's the difference between a 2-point question and a 6-point question with this. But to solve logarithmic equations, you want to isolate / combine logs into a single log. Once you have that, you're going to put it into exponential form. Once it's in exponential form, you're going to solve the equation. It might be a linear equation, or it might be a Mr. X squared. And then you have to check to make sure that your answer is not going to make the whatever comes after the log negative or 0. Also within this lesson, you're going to see a lot of other algebra stuff. You're going to see constant exponential equations. Again, if it's a constant exponential equation, you're going to raise both sides to the reciprocal power. You're going to see fractions in an equation. We saw that here. When you have a fraction equation, you're multiplying by the LCD. You can see a tricky trinomial. If you see a tricky trinomial, use your grouping method. And again, just a hint at the last question, if it doesn't factor, you would have to use quadratic formula. So your classwork / homework is to finish this, and I hope that everybody enjoys the rest of their day.